The video you are watching may be crossing an ocean through glass fibers buried under the sea. A dropped ship anchor can cut them. But fragility is only the opening. The biggest shift is who is buying the cable. Because the companies delivering the cloud are increasingly building the roads beneath it. More than 95% of intercontinental internet traffic travels through subsea cables. The cloud feels weightless, but between continents, it is overwhelmingly a physical network. A request leaves your phone, reaches a nearby data center, enters a coastal landing station, crosses the ocean as pulses of light, and climbs back onto land near another data center. Inside the armored cable, the information moves through hair-thin optical fibers. Steel, copper, and plastic protect those fibers where fishing gear, and anchors are most likely to reach them. Cable faults are routine engineering events, not rare movie plots. The industry records roughly 150 to 200 each year, and about 70 to 80% come from accidental human activity. The cost becomes obvious where there is little redundancy. In January 2022, Tonga's eruption severed its only international cable. Full service took 5 weeks to restore. Networks with several routes can redirect traffic around a break. That redundancy is one reason new cable projects matter. The same demand can take a different road when one road disappears. For decades, telecom carriers and large consortiums built these systems and sold capacity to other networks. Around 2015, technology companies started investing in and building cables themselves. CSIS reports that Amazon, Google, Meta, and Microsoft now own or lease around half of the bandwidth carried under the ocean. That is bandwidth, not half of every cable and not half of the entire internet. Why build instead of simply rent? At hyperscale, cloud firms are among the largest buyers of international capacity. Ownership gives them a larger planned supply on the routes their services need most. A leased connection is like reserving lanes on someone else's highway. A fiber pair in a cable is closer. To owning dedicated lanes, more control over capacity planning, routing, upgrades, and backup paths. Google's scale makes the logic visible. In April 2025, it reported more than 2 million miles of fiber supporting its network, and 33 subsea cables. Meta is pushing the same model further. Its announced Project Waterworth is planned to span more than 50,000 kilometers, reach 5 continents, and open 3 new ocean corridors. Waterworth is designed with 24 fiber pairs. According to Meta, typical new systems use 8 to 16. More pairs mean more independent glass paths inside one armored cable. That creates a vertical stack. The company can operate the service, the data centers, much of the private backbone, and capacity inside the ocean cable joining them. That does not mean one company owns the internet. Traffic still crosses many networks, landing stations, exchange points, and local providers. The important change is concentrated control over strategically valuable capacity. That control has practical value. Companies can choose routes, add redundancy, plan latency, and reserve capacity for their own services. It also gives private firms greater influence over critical public infrastructure. The Pacific Light Cable Network shows how quickly infrastructure becomes geopolitics. US authorities rejected its Hong Kong connection. So Google and Meta revised the system to connect the United States with Taiwan and the Philippines. The trade-off is real. Governments see security risks in where cables land and who can access them. But blocking a route can also reduce resilience, competition, and economic access. So the quiet story under the ocean is not a secret switch that controls everything. It is a shift in who makes the infrastructure decisions, from companies. That sold network capacity to companies whose products consume it. The cloud has a seabed, and its owners are changing. If hidden systems like this are worth your time, subscribe. Next, we will follow one of these cables on shore and into the data centers it was built to serve.